continuous state reactors are widely used in the productions, more than 70%. Describe the component of the mixing system. We've already covered that, and it's straightforward in your note. The importance of achieving suitable mixing, you have done it in one of your assignments, and also straight in your note. Describe the design requirement of continuous state tanks. That covers the entire portion of the bioreactors, which they have to withstand repeated cyclosterilizations. They have to be able to achieve proper mixing of the nutrients, and so on and so forth. All the criteria listed on the criteria listed on the design requirements of the reactor has to be stated in addition to the core area, which they ask to talk about the baffle location, the baffle, and ask about the locations for impellers. Of course, the impellers are located, the spar guy is located below the impellers. Okay, that has to be stated that the spar guy is located below the impeller here. Question 2, you're given let's say the following experimental data were obtained in a batch culture of SRVC on glucose media. You have the process time, the first column. You have the cell concentration, that is the cell biomass that is increasing over time. You have the glucose within the reactor that's diminishing because cells are feeding on the glucose. Okay, let me just repeat. First, you have the process time, you have the cell concentration, and you have the glucose concentrations that will diminish. Just a quick note here is, you see that cells are growing. That's why the biomass is increasing. Cells are feeding on the glucose. That's why we start from 60, then it decreases 50, 40, because cells are consuming the glucose. Now, questions given to you as to find the specific growth rate to obtain the doubling time, the cell yield per gram of substrate, and the last question is, what's the maximum biomass concentrations that could be achieved if you're dealing with 120 grams of glucose, okay, in the reactor. Now, straightforward. Our mu is equal to ln of x2 minus x1. X2 is a final cell concentration. X1 is initial cell concentration divided by T2, final process time minus the time it started. For this to be accurate, for this computation to be accurate, it has to be applied exponential phase. In other words, while carrying out your computations, you may not go from 0 hour to 32 hours, but you could actually go from 3 hours to maybe 32 hours, assuming that between 0 and 3 hours, that was a lag phase. Let me repeat. While applying this formula, your X2, X1, T2, T1 will be taken with respect to, starting at 3 hours, the corresponding cell concentration will be 3.2, and the process terminating at 32 hours, and the corresponding cell concentration 25.9. If you take like that, it's correct because you are assuming that 0 hours and the corresponding biomass were the lag phase. I will know for sure that this equation is useful or applied or is accurate only at exponential phase. By applying that, you're going to obtain your specific growth rate, mu. Question 2 says, find the doubling time. Okay, this is straightforward, copy and paste from your class. You know mu already, right? You have obtained mu in the previous example. We know that we work out the relation between mu and the doubling time, right? Class, are we still together, class? Did you cover the relation between mu and doubling time? Okay, I don't want to go through the slide again because it's there in the slide. Now, again, if you know mu already, simply you apply the formula after obtaining your mu, that TD equals 0.69 divided by mu, you have mu. And you have the other component of the equation. By applying this simple formula, having obtained mu from the previous computation, applying this will give you your TD value. The next thing is to find the yield. Okay. We said the yield is a change in cell formation divided by the change in the substrate concentration. That is, you're going to come back to the table, find out the total amount of biomass produced, maybe 25.9 minus 3.2 or minus 0.8, divide by how much substrate did they use. They start from 60 grams of glucose, they use up down to 0.2. Okay. When you do the difference here, and we will do the difference here, they're going to give, sorry, difference or the biomass produced, cell concentration divided by the glucose used, they're going to give you your yield. Thus, by applying this formula, you're going to obtain the yield. The simplest calculation was the last one. Here they said if 100 grams of glucose were used, what would be the mass of cell produced, the biomass produced? We simply multiply the yield obtained here by the amount of glucose. Okay, if they say 100 grams of glucose, we're going to replace here by 100 grams of glucose and multiply that the yield to have an idea of the mass of cells or the biomass that will be achieved. Class O was able to solve the different aspects as I've explained. If we did the exact step, we'll get a different answer based on a different scales. Yeah, I will definitely look at it thoroughly. If you've done the correct things and use different scales, I will check it to see where the problem lies. Okay, O was able to get to answer all the question accurately. Each group. All right. Thank you very much for listening. Then I'll stop here for today. We'll stop here for today.